Alright, in this section here we will be working some problems, polynomial and rational inequalities, and we'll be finding their solution sets and writing them in interval notation. So let's move on over to the whiteboard and get started. Alright, let's start off with, of course, we always start off with something easy. And here we'll give this one a number here. So let's start off with x squared is less than 10 minus 3x. That should be an M right there. It's not dot, I think there is a .co now. It's .com. Okay, I need to fix that. What we'll want to do here is get this thing in standard form, and let me just shift to the left. Let's go ahead and take this 3x over to the left so it becomes a positive 3x. And let's take the 10 over. Minus 10 is less than 0. So we factored some quadratics in some earlier sections and found the solutions to the equations. And basically that's what we're going to do here, except we're going to add a few more steps. Okay, so let's go ahead and factor this. This is a pretty easy one here. We'll set it up like this at first. Alright, go ahead and rewrite that part. Okay, so two numbers multiplied together gives us negative 10, and when we add them, we get 3. So what about 5 and 2, right? We know that 2 times 5 is 10, and we know that 5 minus 2 is positive 3. So let's put a plus sign here and a minus sign right here. Okay, so as you can see here, if the zeros of this guy are going to be negative 5 and 2, right? Because when I plug negative 5 in, I get 0, and when I plug 2 in, I get 0 also. Alright. What we're going to do now is we're going to draw a graph. Now, of course, this is just a one-dimensional graph. Right. And we're going to go ahead and label our zeros. We call these our zeros here, and we will label them on the graph. Alright, so let's put negative 5 right here, and we'll put 2 right here. Okay, so the next thing what we'll want to do is we're going to do what are called some test points here, and I don't know, we use a different color for test points. How's that? So pick a number to the left of negative 5, and how about negative 6? That's a good one. And then we'll pick 0 here, and always pick 0 if you can. And then we'll pick a 3 here because it's easy to plug 0 in and find out if it's negative or positive. And so that's what we're going to be doing now. Okay. So what we're going to do here is we're going to plug in negative 6, and let's see, how do I want to do this? Negative 6. We'll draw an arrow here. What we're going to do is plug in negative 6 into this. So negative 6 plus 5 is a negative number. Okay, negative 6 minus 2 is a negative number, and a negative times a negative is a positive. Alright, negative times a negative is a positive, so we're going to put a positive sign right there. Right, and then what we'll do is 0, plug 0 in, so 0 plus 5 is 5, 0 minus 2 is negative 2, and a positive times a negative is negative. Right, we'll put a negative sign there, and then we'll plug in 3. Alright, so 3 plus 5 is a positive number, 3 minus 2 is a positive, and a positive times a positive is positive. Alright, put the positive sign here. Okay, so this inequality here is this, whatever this is, it must be less than 0. So in other words, what's less than 0? Well, it's just all negative numbers. All the negative numbers are the ones that are less than 0. Okay? And we do include, we can't include, I should say we can't. And we don't include negative 5, so we're going to put a parentheses around this. And then we'll put a parentheses around that right there, between negative 5 and 2. So we can use all the numbers between negative 5 and 2, but we can't include negative 5 and 2 because this inequality doesn't have the equal sign under it. You see that? And so we'll write that interval, and I didn't really mean to do it in red. I got so many colors going on here. Alright, so we're going to write that interval between negative 5 and 2. Okay? Between negative 5 and 2. Now this is interval notation. If we wanted to write the inequality notation, we would say x is greater than negative 5 and x is less than 2. X is less than 2. Okay. Alright, well let's take a look at another one. That was pretty easy, I guess. It is compared to what we're going to be doing here in a minute. Yeah, don't mean to scare you. Alright, so let's go with, this is 2 here. Alright, so we'll go with x squared plus x is less than 12. Less than 12. So we want to get this in standard form. So we're going to write x squared plus x minus 12. Bring that 12 over to the left-hand side and set it equal to 0. Now we'll want to factor this. Of course, that's one of the techniques for finding the zeros. And since we're learning this for the first time, let's say, we're going to do some easy ones where we can just factor them. Okay, so two numbers multiplied together gives us 12, and when we add them, we get a positive 1 here. And that looks like probably 3 and 4. Right, and this is going to be a minus, and this will be a plus. Forgot to write an x here. Okay, so the real zeros, we could write real zeros here. The real zeros are going to be 3 and negative 4. Right, that's what makes this 0, and that's what makes this 0. Okay, and then what we'll do now is, let's draw a graph. Alright, let's label our zeros on the graph. So we have negative 4 and 3. Okay, and now what we'll do is our test points, and our test points were in orange, so we want to probably stick with that same color scheme. And of course I used green for the number line. Wow. Okay, let's try something different here. How about green this time? Okay, so our test points are going to be negative 5, 0, and we'll use 4. Alright. Okay. Okay. So let's look at negative 5. Negative 5. When we plug negative 5 in up here, we get a negative number, right? Negative 8. Plug negative 5, we get a negative number, and a negative times a negative is a positive number, so we're going to put a positive sign right above that. And then take a look at 0 here. So take 0, plug it in, you get a negative. Take 0, plug it in, you get a positive. 0 plus 4 is 4, right? And you got a negative times a positive, and that's going to be negative. And we need to write that above there. And let's do one more, 4. So plug 4 minus 3 is 1, and 4 plus 4 is 8. And so we get a positive times a positive, and that is positive. Okay. So this sign right here, right, this number's got to be less than 0, which means it has to be a negative number. Okay, it has to be a negative number. So that means that we're going to be looking at just this interval right here. Right, just this interval right here. Now we can't use -4 and we can't use 3, because if we use -4, right, we end up getting 0 here, and 0 times a number is 0, and 0 can't be less than 0. So you can't have 0 less than 0, so we can't use -4. Alright, so we'll go ahead and write this interval notation. Our solution set is between -4 and 3. Right. And that's interval notation. Our inequality notation would be x is less than -4 and x is x is greater than -4 and x is less than 3. Less than 3 there. All right. Okay, we are moving right along. So let's take a look here at number 3. All right. So we have x squared plus 21 is greater than 10x. So we want to get this in standard form, and that's going to be x squared minus 10x plus 21 is greater than 0. Okay, so let's go ahead and factor this. Alright, so what about 7 and 3? And since this is a minus sign right here, wait a minute. Yep, that'll have to be minus and minus, because -7 times -3 is a positive 21, and when we add them we get -10. Okay, so the real zeros in this one are going to be 7 and 3, because when I plug 7 in I get 0 here. When I plug 3 in I get 0. Okay. Alright, let's now draw a graph. I guess we'll go back to, boy, that's not exactly a straight line. Not exactly. So let's go ahead and label 3 here and 7 here. How's that? Okay. Alright. So our test points will be 0 and what's another test point? 4. I guess 4 is a test point. And then we'll use 8. 8 is a test point. Okay. So we take our test points and we plug them in up here to determine if it's going to be positive or negative. And you know what? We'll skip that step there. So let's plug 0 in. So we get a negative. Plug 0 in. 0 minus 3, you get a -3. So you get a negative times a negative, and that's going to make that a positive. Take 4, plug it in. 4 minus 7, that'll be a negative number. 4 minus 3, that's a positive, and a negative times a positive is negative. Now let's take 8. 8 minus 7 is a positive. 8 minus 3 is a positive, so that's going to be a positive. Okay. Now you can pick any number you want to the right of 7. I just picked 8. You can pick 9, 10, 11, 12. It doesn't matter. You could pick a fraction. You could pick an irrational. Whatever you want to do, right? But pick something that's easy, like 0 is easy, right? Okay, so we got that. Now let's take a look at our inequality here. Now this number must be greater than 0. In other words, it's a positive number, positive integer, right? It must be greater than 0. Okay, it's got to be a positive. So we're looking at everything to the left of 3, but it can't include 3, because remember, if we include 3, we get 0 here, and 0 times a number is 0, and 0 can't be greater than 0, so we can't use 3. Right? But we can use anything to the left of 3 on the number line, and that means all the way out to negative infinity. Well, I mean, we can't use negative infinity, but you get the picture, right? Use it in parentheses here because we can't use 3. All right. Union. Okay, the symbol right here, union, means we're just joining both of these intervals, and now we're going to go from 7 to positive infinity. Okay, to positive infinity, right? So we'd end up setting this up as two separate inequalities, where x is greater than negative infinity, less than 3, and then we would write the other inequality as x is greater than 7 and less than infinity, and I'll leave that to you. Okay, so this is pretty easy. We're finding the solutions to this inequality up here. All right. Let's look at number 4. We have x squared plus 5x is less than or equal to 0. Less than or equal to 0. So let's go ahead and factor this. We're going to have x, just pulling an x out there, and an x plus 5 is less than or equal to 0. Okay, so the real zeros, not the fake ones, are going to be 0 and negative 5, right? That's what makes this side 0. Plug 0 in, 0 times the number is 0, and plug negative 5 in, negative 5 plus 5 is 0. So we set both these factors equal to 0. And I'm kind of skipping that step, hoping that you know that. So there's some intermediate steps that I'm not really taking. Okay, assuming that you already know those intermediate steps. So let's go ahead and we'll put negative 5 right here, and we'll put 0 right there. Okay, and that's now pick some test points. How about negative 6? And what about negative 1? That's a good one. And 1. Okay, some easy ones there. Alright, so let's take a look at this. Negative 6, if we plug this in up here, we get a negative number, right? And then negative 6 plus 5 is a negative number, and a negative times a negative is a positive, right? And let's see, let's take a look at negative 1. So this is going to be negative 1 times, and then this will be negative 1 plus 5, which is 4, and a negative times a positive is negative. See that? And then let's go with 1. So that's obviously going to be 1 times 6, so that's a positive times positive is a positive. Now looking at this inequality here, this number must be less than or equal to 0. Now you see this right here, equal to means we can include these guys right here, okay? And it must be less than 0, so it must be a negative. So we're looking at, I guess I didn't do this on the last problem, but we're going to include, there's a couple ways of doing this. You can use brackets or a filled in circle, either way. Alright, so we're going to be including negative 5 and 0. So we're going to write this now in interval notation. Right, negative 5 and 0. And of course, if you wanted to write this in inequality notation, it would be x is greater than negative 5 and less than 0. See a mistake here? Yep, got to put that in there right there, okay? Because that means x is greater than or equal to negative 5, or x is less than or equal to 0. All right. Okay, you are coming right along with this stuff. Alright, and that was number, what was that? That was number 4, so this looks like number 5 here. Number 5. Okay, so we have x squared is less than or equal to 9. Now there's a couple ways of doing this. Remember that square root property where we could square root both sides and then just say plus or minus? Okay, we could do that, or we could do it like we've been doing it, which that's the way I'm going to do it. And just get this thing in the standard form. Bring everything over here to the left. We factor this. This becomes x minus whoops, x minus 3 times x plus 3. Right. Okay, so we'll want to find our real zeros, and that's just going to be 3 and negative 3. Okay, so those are the real zeros there. Not the fake zeros, but the real ones. Alright, let's draw a number line. Let's plot our real zeros on here. So we have negative 3 and positive 3. And now what we'll do is some test points. And let's just pick negative 4. Always pick 0. That's always an easy one. And then we'll pick, 4 here? Right, pick 4. Okay. Alright, so let's go ahead and plug these test points in and see if it's positive or negative. So we plug negative 4 in. We get a negative number, right? Because negative 4 minus 3 is a negative 7. So I'm not doing the math on that. I'm just saying, is this negative or positive? So plug negative 4 in, you get a negative number, negative 4. You get a negative number, right? And a negative times a negative is a positive. Now let's take 0. That's going to be 0 minus 3, so that's going to be negative. 0 plus 3 is a positive, and a negative times a positive is a negative. Now we plug 4 in, that's going to be positive. That'll be positive, so that should be positive. Alright. Okay, well, let's take a look at this now. This says less than or equal to 0, so we're going to include these points here, right? And this number must be, okay, is less than or equal to 0 means it's got to be a negative number. So we look inside this interval here. This is the interval we're going to be looking inside right here. As you can see, these would be all the negative numbers, including the endpoints for that. So we write that in interval notation from negative 3 to 3. Alright, and of course you can write that in inequality notation. X is greater than negative 3, greater than or equal to negative 3, and x is less than or equal to 3. Alright. Okay. Let's see. Oh, now we're going to something a little bit more difficult. Gotta throw a little twist in here. So we have this rational number, x minus 2. Remember, the title was polynomial. Polynomial, that's what we just got to doing, and rational inequalities. So we have x minus 2 over x plus 4, and that is less than or equal to 0. Less than or equal to 0. So what we're going to do is first start off with the x minus 2, right? Set that equal to 0, so the real zeros of that is going to be 2, right? Plug 2 in, you get 2 minus 2 is 0. And then we'll look at x plus 4 and set that equal to 0, solve for x, so that's going to be a negative 4. So the real zeros are 2 and negative 4. See that? 2 and negative 4, that's our real zeros. Yeah. Alright, well, just like we did in the previous problem with just the polynomial, we're going to do our graph, and we're going to plot our zeros, negative 4 and 2. Now there's something that you need to keep in mind here. Alright, we can't use negative 4 if it's in the denominator here, and the reason for that is because you can't divide by 0. So one thing we know about negative 4, we can't use it. So I'm just going to go ahead and put an open circle right here, right? And we're going to work several of these problems so you'll understand what's going on that. Right. So let's go ahead and choose our test points now. So we have negative 5. Of course, we always use 0 if we can, and we'll use 3. Okay. Alright, so here we go. So you take negative 5, you plug it in up here at the top. So that's going to end up being a negative number. And you know what? We're going to just write this down here. So negative 5, plugging negative 5 in up here in the numerator, you get what? Negative 7, so it's a negative number. And then plugging negative 5 down here in the denominator, that's a negative, and so we end up with a negative over a negative is a positive. Okay, and we'll go ahead and write that right there. Alright, okay, so let's go ahead now and take a look at 0. So plugging 0 in, you get a negative in the numerator. Plug 0 in, you get a positive. So that's negative over positive, and a negative number over a positive number is just a negative number. And then now we go ahead and look at 3. So we get a positive over a positive, and that would be so positive over positive, and that's going to give us a positive number. A positive number divided by a positive number, you get a positive number. And I guess I should have been writing this up here. Alright, so now we can take a look at this. Now remember, we can't use negative 4. Okay, so we got to keep that in mind. Now this number right here must be less than or equal to 0, which means it must be negative, a negative number, and it can equal 0. Okay, it can equal 0, but it must be negative. So let's take a look at this. So between negative 4 and 2, this is where all the negative numbers, right, all the numbers for our solution. We can't use negative 4, but we can use 2, but it can include 2 because that will give us 0 here, and 0 over a number is 0. 0 over a number other than 0, right, is actually equal to 0. Okay, so we'll go ahead and write that. So between negative 4 and 2, and of course we include 2 here. Right. Okay, that wasn't too bad. Looks like I've run out of room. Okay, what are we doing now? Oh, we're going to continue to do those problems, it looks like. Okay. Well, it looks like in this section here, something happened to my audio, and I don't know what happened to it, but we're going to be going silent here. I guess for the next 27 minutes. I mean, I don't know if that's what I want to do or not, but so as you can see here, we're setting the numerator equal to 0 and finding the real zeros. And it looks like, so we've got negative 4. And then of course we're going to look at the denominator and see what that makes. That makes 0, and that's going to be 1. Okay. And we'll go ahead and draw a graph now, labeling negative 4, negative 1 on the graph. Okay, now remember, we can't use 1, so that's the reason we put a circle around that 1 there. That helps us to remind us that we can't use it. Okay, and we'll go ahead and label our test numbers there on the graph: negative 5, 0, and 2. Alright, so let's take a look at negative 5. Alright, so we plug -5 into the numerator and we end up getting a negative number, right? -5 plus 4 is -1, and then plugging -5 into the denominator, we get 1 minus -5 is going to give us a positive 6. That'd be a plus. So we have minus over positive makes that a negative. Now we've got, go ahead plug 0 in, our other test point. So 0 in the numerator gives us a positive, and then 0 in the denominator gives us a positive. 1 minus 0 is just 1. So positive over a positive gives us a positive. Easy enough. Okay, now we'll plug 2 in. So 2 plus 4 is 6, so that's a positive, and 2 in the denominator, 1 minus 2 is a negative. So a positive over a negative is a negative. Easy enough. Okay, so what I should have been doing is putting our signs above our test numbers there. So remember now that this expression up here, x plus 4 over 1 minus x, must be less than or equal to 0. And so therefore the interval must be negative. Okay, must be negative. So we got to look at between negative infinity and -4. Okay, and then between 1 and positive infinity. All right, now remember we cannot include 1. We don't include it. Okay, don't include it. So after this problem here, we're going to go silent. You should be able to follow me. Like I said, I had some problems with the don't know the audio when I went to play back this, so I'm having to record the audio again. So I don't know what happened. It's terrible. Okay, so good luck, and I will see you in the next section. So there's a few more problems left in this section, and like I said, we'll be going silent on that. So hopefully you'll be able to keep up. All right, see you in the next section.